Hello everyone, welcome to VKS YouTube channel. In this video, we are going to discuss all about simple linear regression. So, simple linear regression, what exactly the meaning of simple linear regression? So, first of all, this one is the first linear regression algorithm. Basically, whenever we talk about the linear regression, so the linear regression, it is split into three types. So the first concept is the simple linear regression. So right now we are focusing on this topic. So right now let's understand clearly what exactly the simple linear regression. Let's take an example so that for the better clarity. So here there is a one data set is there which is having, and this one is the data set. This one is the data set. And here in this data set, so there is a height is there and there is a weight is there also. So here we have to focus, like here we have to just find out what exactly the relationship between the weight and height. Here, suppose we want to predict a person weight based on their height. It means what? So here we collect the data on height and weight for a sample of one people, right? So here, first of all, whenever you are having one data set, so your first focus should be what? Like to create one visualization. Like based on it, you have to just go for the one visualization. So right now, I'm just focusing like to visualize this plot. Okay, think that this is plot. This plot is visualizing. This plot is visualized like this. So these are the data point. These are the data, right? So here, according to this data point, our goal is what? Like to draw one line so that that line should be average of this. Like if you will just measure the like the distance between the data point and this line should be what? The distance should be what? Minimum. Like you can say also constant also. You get my point? So as the algorithm name is the simple linear regression, that's why this line is created with the help of this equation, which is the y equal to mx plus c. And hence you clear that this one is a what? Linear line. As the algorithm name is the simple linear regression, so that's why, so we are focusing to create one model, and hence this line is nothing but the one of the model. Now if you will go for that equation, and now so there is a one clarity will be there. This y is nothing but what? This part, which is known as the predicted side or the predicted part. Okay, predicted variable. And now this x is nothing but the what? The features, you can say. How many features are there? Now we are having how many features? We are having only one features. That one is the independent features. I'm talking about the independent features. So here, this part is the y, which is the predicted part. And this part is what? I'm just taking, this one is the independent part, right? X features, you can say. So hence, here height is nothing but the x1. So as the one column is there, so x is only there. If the x will be increased, then there will be what? Increase. Then I will explain it in the next upcoming video. So then go for the next part. that one is the C, which is known as the intercept. This part is nothing but the intercept. Intercept. So this intercept is nothing but wherever this line, now you already cleared that this line is nothing but the regression line. This line is nothing but the regression line. Regression line. Now, as the regression line is touching, okay, this line should be touched in the y side, not always. Like if it will be touched in the y side, it is touched in the y side. It means what? So this part, the value here, whatever will be present, that part is nothing but the intercept value. That part is nothing but the intercept value. So hence, this one is nothing but the linear regression. So as the x value is something, okay, let assume, so here 60, then what, assume that the value, the data point will be what? So here 140 will be there. As it will be moved, okay, then it will be what? The output will be what? Like this. It will become like this. 155. So hence this one is the what? Regression. Because now this part is what? Our target part. This part is our target part. Now look at this target part. 140, 155, 159. So you can also call it as a, these all are the real value, you can say that. Or you can say that these are the continuous value, continuous number, right? These are the continuous. So if you are like facing this type of output, this one is known as the regression concept. And based on this plot, we'll say that is it simple linear or it's any other algorithm is speaking. Let's go for that one line. How if the data point is splitted according to the data set, then how the line will be what fit? Like here, the point is what you have to make one line so that it will be what best fit. Best fit in the sense what? So here, if we'll just measure one data point distance, this line is nothing but the what predictor line. Here in the machine learning, so wherever I'm saying, we are just saying that the prediction part. So here, this line will be predict something. Here, this line will be predict something. It means what? So here, this one is the prediction line, and all the data point, these all are the nothing but the what actual part. So always remember, this part is the actual value. What is the actual value? Actual value means inside the part, whatever inside the data set, whatever given. So that one is the actual value. But whenever it will be asked to the model, can you just predict something? So he will just predict these things, like, sorry, this part. Okay. If the actual part is the 159, then he will just predict something. Okay. Near to 50. Like he can just predict 149. So it will only predict the things. Okay. So right now, after it, we'll just find out like how much percentage he's just giving the correct answer. So which is also known as the model accuracy. Let's go for like if the data point will be split, then how the line will be fit in based on. Now you can just look at this example. This one is the one diagram. So wherever the green colors are nothing but the green colors are nothing but these are the data points. Now these are the data points. Okay. So as the data point is splitted, now this line is nothing but what? This line is the regression line. Okay. Always remember this red line is nothing but the regression line. Regression line. Now, so here the line is moving. It means what? Now you can just focus here. Now the line end part is continuously it's moving. Now you can say that, so here the intercept value is what? Changing. Yes or no? So now according to this part, so here the line is what? Line is want to just fit in the best way so that if any new value will become, he will just predict in the with the good answer. Clear? So this is the best fit line. How exactly the model is what fitted in best format. So now let's move through like what exactly the difference is it? Okay, what exactly the difference is it? So if we'll just go for this difference, as the difference is what? So here some of the difference is what there. So this difference is nothing but known as a residual. Residual. Clear? So if we'll go for what exactly the residual is it? What exactly the residual is it? So in your mind, the question will become like this. So here, if we'll go for the residual part, the residual is nothing but what? These D1, D2, here, the D3 and D4, all these are the data point, which is nothing but the actual value. These are nothing but the actual value. So here, actual value, actual value, actual value, then negative, predicted value, negative, predicted value. So if we'll go for this part, now see, look at this part. So this is some gap is there. And this part is nothing but the residual. Or you can say that this one is the error part. Why we're saying that error? Because the data point value is something, but the model is predicting something. So this gap is nothing but the what? He just predicting the answer. If you will just predict the answer, it means what? It should be what? Approximate value. Okay, so our goal is what? The approximate means the distance should be what? Minimize. If the correct answer is 150 and your answer is what you are, whenever you are solving the mathematical equation and your answer is coming 130, it means what? We can say you are saying that approximate, but now just look at what exactly the gap. The gap is 20. Will it be correct answer? No. So right now, what we have to just focus, we have to focus, the answer should become closer to the answer. And that can is called as a perfect approximate value. So here in this simple linear regression, next time, so our goal is what? To make it what? To make it minimize. To make the minimize error. To minimize the error. So for minimize the error, we will what? We will just adjust this line. Now you can just go for the next page. Now check out this part. Now we are how we are just adjusting this line and how we are just calculating the error part. Now as the line is what increasing, the error part is also what increasing. For some part it is increasing, for some part it is what decreasing. So here, as I already just explained, we'll go for the what? Residual. Residual. The residual is what? The actual value. Actual value, actual value, negative predicted value. Predicted value. So here, whatever value, like for example, this value is nothing but what? 140. And this value, the predicted value is nothing but assume that 130. So here, the gap is what? The first residual. First residual error is what? 10. And then if we'll go for the second part is what? Like 120, but the model is predicting, assume that this part. Okay, so now again, the R2 is what? Negative 10. Next, this part is what? 155, but this part is what? Now, if we'll go for this regression line, now it is predicting like this here only. So assume that this part is what? 135. Now, if we'll just go for the difference, if we'll go for the difference, now the difference is what? R3 is nothing but the 20. So likewise, the residual error part will become, if we'll just find out the error now, you can just sum all this. So then after that, you will just find out total how many errors are there. So as in the previous video, I just discussed all about the assumption part. I just discussed all about the assumption part. So if you will not check out the next video, you can just check out the next video part. So in that part, I just explained all about the assumption part. So first part is the what? Linearity. What exactly the meaning of linearity? So here we're finding out the relationship between the what? The X and the Y, right? The X and the Y. So here, according to our statement, so here Y is the weight part and X is the height part. So here we are just finding out the relationship between the weight and height. So here this one is nothing but the what? Linearity. This line is linearity. Now second assumption is what? Second assumption is the independence. Here each data point is independent of others. It means what? So this data point is the one independent part. This data point is independent, like 140 is there, one independent value. This data point is having another independent value, 120. This data point is having another independent value, 155. So that's why it is saying that independence. Now, next part is what? Now, if I will just draw the perfect line. Okay, I just draw this perfect line. Now look at this red line. And now check out the distance between this and this and the distance between this and this. So now you will just check, seen that. So there the distance between all are what? Now constant. These distance is what? Constant. Constant. So as this distance is constant, so we are just saying that what? Homoskedasticity. Homoskedasticity. This one is the homoskedasticity. It means what? So here the data point is what? So here the data point is splitted in the same way as the error is constant. So now in your mind, maybe question is arise like, okay, so what exactly if the data point is not constant? Then what is the meaning of this part, or what is the name of this term? This term is nothing but the what? You can just say that this assumption is nothing but the heteroskedasticity. This is the one of the most interview questions. Now, if we'll go for the next assumption, that part is the normality. Normality in the sense what? So here, the error term is normally distributed. Now, if we'll go for the last part, that one is the no multi linearity. So this part is nothing but the here this height and weight are not highly correlated with other variable because we are having only two parts, the X and Y, right? So in this video, so we are just explaining all about that error part. So in next video, we will come up with one example, the numerical example, what exactly the mathematical intuition part is there. So we will just discuss it and we will just solve multiple questions. And then after that, we will just come up with the implementation part. So thank you. If you just like the video, so please just do like it and subscribe the video, subscribe to the VKS channel. And if you're getting any doubt, you can just ask me in the comment box. That's it. Thank you. Bye-bye.